Nice to meet you. I'm Khadar Juqai and you're watching my YouTube channel School of Advanced Chemistry. Today I'm going to discuss the new topic that is how to draw a dot and cross diagram for covalent molecules, for covalent compounds, for A-level chemistry students. Let's jump into it. So point number one, draw the Lewis structure according to the normal valencies. Lewis structure, line structure, Lewis diagram with respect to their normal valencies. What are the normal valencies? For example, in case of carbon's normal valency bond making capacity is called valency, that is equal to 4. Normal valency of the nitrogen is equal to 3. I mean, nitrogen normally can make 3 bonds. Normal valency of oxygen, it can make 2 bonds. Its normal valency is 2. And normal valency of the hydrogen is equal to 1. Hydrogen can make 1 bond. Same is the case for the halogens. So basically carbon usually makes 4 bonds, nitrogen 3 bonds, oxygen 2 bonds, hydrogen 1, and fluorine family also make 1 covalent bond. Now nitrogen can exceed its valency. It can make 4 bonds. Yes, it is true. It can make 4 covalent bonds, but at that time it's going to have 1 positive ion on nitrogen on central atom. Yes. In case of oxygen, it can also exceed its 1 valency, and again it's also having 1 positive charge on it in this case. Carbon usually makes 4, but it can make 2 bonds as well. Carbon can make, sometime can make 2 bonds, but these are the rare bonds. This is the rare valency. Usually it makes 4 covalent bonds. Its valency is 4. Nitrogen valency is equal to 3. Oxygen valency is equal to 2. Hydrogen is always making just 1 bond. Normal valency of the fluorine. Normal. It's a normal that is highly usual, you can say. The next point is mark lone pair. What are the lone pair? Lone pair is a pair of electron that is not taking part in covalent bonding. Lone pair of electron is the pair of electron that is residing in the last shell of electron, in the last shell of an atom, but it is not taking part in bonding. That is called lone pair. So according to the last shell electron, we will mark lone pair. For example, in case of NH3, NH3. So this nitrogen is having 3 valencies. Hydrogen is having 1 valency. Its valency is equal to 3. Its valency is equal to 1. So as the nitrogen is having a higher valency, I am going to draw nitrogen first. Then I will attach 3 hydrogen with it. 3 hydrogen with it. Now you can see that nitrogen has used its 3 valence electron with the covalent bond formation with hydrogen atom. Overall, there are 5 electrons lying in its last shell. So 2 electrons are over here, and this pair of electron, these 2 electrons is said to be the lone pair. So here is the lone pair of electron. It is said to be the lone pair of electron. Next rule number 3, atoms. All atoms should follow the octet rule. I mean, all atoms must be having or should be having 8 electrons in their last shell. There must be 8 electrons. That is said to be complete octet, and it is also said to be an octet rule. 4 number, in case of an ion, in case of positive ion or in case of any negative ion, total number of electrons must be same. Total number of electron. I mean, if you're using 1 negative ion, for example, I'm supposed to draw the dot and cross diagram for OH negative ion, and examiner is asking to draw the last shell electron. So how many last shell electron should be drawn over here? This oxygen is having 6 last shell. This hydrogen is having 1 last shell and 1 electron because of this negative charge. So total last shell electron must be equal to 8. So I mean, in case of anion, you should be focused on the last shell electron as well. So the number of electron must be the same. Point number 5, oxygen atoms and the carbon atom share usually even electrons in case of covalent or in case of coordinate bond. I mean oxygen atom. Either it will share 2 electrons, it's 2 electrons, or it will gain 2 electrons. I mean, it can make coordinate bond. Yes, it is true. Oxygen atom can make coordinate bond and it can share or it can accept the pair of electron that is said to be the coordinate bond. And similarly, rule number 1, oxygen can share 2 electrons, not 1. So whenever you are going to share or going to make the covalent molecule of oxygen, either it will share 2 electrons or it will accept the pair of electron. And same is the case with the carbon atom. Carbon atom always share even number of electrons, 2 electrons, 4 electrons, and so on. The next point is, if the positive and negative charges are appearing on adjacent atoms, then these will be cancelled out. Overall molecule will be the neutral molecule. For example, when NH3 is allowed to react with BF3, there is the formation of this molecule that is said to be adduct. And in fact, this nitrogen is having positive charge, as I have told you, that nitrogen is making 4 bonds, so it is having positive ion. And this boron has accept 1 electron, so it is having negative charge on it. So it will be cancelled out. Overall molecule will be a neutral molecule, and so on. The next thing is mark dot for one atom and cross for the neighboring atom. So you will start from left to right, dot for one atom, cross for the next atom, again dot for one atom, cross for the next atom, and so on. Finally, you will remove the bonds of the Lewis structure, and there will be dot and cross left behind, and that is the dot and cross diagram. There is no need to draw the circle every time, but if he or she is asking to draw the circle, then you can draw, you should draw, you must draw it. Now come towards few examples. For example, in this question that is having already circles and the basic skeletal of the atoms, carbon, hydrogen, oxygen, oxygen, hydrogen. Complete dot and cross diagram showing the outer electrons only to show the bonding in methanoic acid. So this is the methanoic acid basically. You are familiar with the structure of methanoic acid. This is Lewis diagram of the methanoic acid. So carbon is making 4 bonds, oxygen is making 2 bonds, each hydrogen is making 1 bond. So now I am going to mark dot and cross. For hydrogen dot, let's suppose for carbon, the electron of carbon is cross. 4 electrons in this scenario, I mean. And so I put 4 crosses across the carbon, and again dot, cross. So for oxygen, this oxygen, I'm using dot, that's it, that is the electron of oxygen. Again dot and cross for hydrogen in this case, and in this oxygen I'm using dots. So I simply change these line into dot cross, dot cross, dot cross. Now I'm going to check the last shell electrons. I mean, I'm going to mark the lone pairs. This oxygen atom is basically having overall 6 electron. This oxygen has used 2 electron in bonding. Rest of 4 electrons are lying in form of 2 lone pairs. Same is the case with this oxygen. It has used 2 electrons only in the bonding, in covalent bond formation, and rest of 4 electrons are lying in form of lone pairs. Now I am going to remove these bonds, these lines, and this is the dot and cross diagram. Basically, I'm going to rearrange these dot and cross. Let's see over here. So here 1 dot 1 cross, that is the sharing portion between the carbon and hydrogen. Here is the 2 cross from carbon, 2 dot from oxygen in the sharing region of the oxygen and carbon. I'm removing these electron. In this Next, carbon oxygen region. I'm marking one dot, one cross, dot and cross. And same is the case with the last one. Hydrogen oxygen bond, that is again showing dot and cross because of the hydrogen atom, and this is the dot and cross diagram. Now come towards the next example. Draw a dot and cross diagram to show the arrangement of outer shell electron in carbon monoxide molecule. Use dot. Now this time there are different restrictions that you will use dot to represent the electron of oxygen atom, and you will use cross for the electron to show the electron of carbon atom. So carbon and oxygen. You know, I have told you oxygen, the normal valency of oxygen is equal to 2, and oxygen can share 2 electron. First of all, it can share 2 electron, it can make 2 bonds. First of all, I'm going to draw these 2 bonds, and the cross carbons electron are cross, and the electron of the oxygen is basically dots. Now come to the next one. There is not any normal condition for the carbon. It must be having 8 electron around it, and either it can share 2 electron or it can share 4 electron. The sharing capability of the carbon is in even mode. So I'm not going to share any further electron for the carbon. I'm making rest of 2 electron. Carbon is having 4 electron in its last shell. So I'm going to make a 1 lone pair of electron on carbon atom. Now, how to complete 8 electron in this proximity of the carbon and oxygen? Now I'm using 2 more electron from oxygen to make a dative bond from oxygen to carbon. Now 1, 2, 3 and 4. Only 1 lone pair is left with oxygen as well. Now count the pairs and surrounding oxygen and carbon. So then both are having complete octet. So they are both stable in this case. So basically there are 3 bonds between carbon and oxygen atom, 1 lone pair on each atom, 1 on carbon, 1 on oxygen, and so on. I'm going to write it again. So 2 dots, these are the 2 dots, dot, cross and dot, this one, and again cross and dot over here. Here is oxygen with the 2 dot. Here is carbon with the 2 crosses. So this is the dot and cross diagram for carbon monoxide. Come toward the next question. Complete the dot and cross diagram to show the bonding in a molecule of SCl2. Show outer electrons only. The valency of S is equal to 2. The valency of 1 chlorine is equal to 1. So in the middle I'm putting S. Sulfur is the member of oxygen family. So its normal valency, its normal valency will be equal to 2. So I'm drawing it over here. Sulfur and chlorine, bond chlorine. As I told you, chlorine is having normal valency 1 and sulfur is having normal valency that is equal to 2. So let's suppose if I'm showing the electron of sulfur by dot. Sulfur is using only 2 electrons, so rest of 4 electron will be over here in form of 2 lone pairs. This cross is for the electron of chlorine. So the seal is having 6 more electrons in its last shell. So in this way, this Cl is having complete octet. Same is the case for the sulfur. It is also having complete octet. And same is the case for this Cl. It is also having the complete octet. So I'm going to write it again over here. 2 lone pairs. It can be written as, you can write 2 pair of electron on this circle, except this shared region. Here I'm writing dot and cross. and dot and cross. Here is Cl, here is Cl, and here are 3 lone pair for each Cl. Here are 3 lone pairs for each Cl, and so on. So this is the actual correct dot and cross diagram of SCl2. Come to the next question. Draw the dot and cross diagram NH2Cl. Here there are 3 basic elements: nitrogen, hydrogen, Cl. It's making 3 bond. Its normal valency is 3. Its normal valency is 1. Its normal valency is again 1. So I'm writing first of all nitrogen and attaching these rest of the atom with the nitrogen. So let's suppose Cl, 1 hydrogen, 2nd hydrogen, and so on. In this case, again nitrogen is using 3 electron. For example, I'm showing 3 dots for nitrogen. Dots for nitrogen. These dots are electron of nitrogen, and the rest of 2 electron, as the nitrogen is having 5 electron in total, it's a member of group 5 element. It is having 5 electron in its last shell. So the 2 electron, 1 pair of electron will be the lone pair. And cross for the Cl, cross for hydrogen electron, cross for hydrogen electron, and so on. And now come towards the Cl. Cl have been used 1 electron. The rest of electrons are in form of pairs. Now the last portion, I'm checking the octet rule except for hydrogen. Yes, there are overall 8 electrons surrounding the chlorine. It's true. 8 electrons surrounding this nitrogen. It's true. This is the perfect dot and cross diagram. I'm going to erase the bonds. These bond, and here it is. So this is the dot and cross diagram. You can write, you can make the pictures like that. I'm trying to get them closer. So this is the true picture of NH2Cl dot and cross diagram, dot and cross picture. Now come towards the peroxide ion, that is O2, 2 negative ion, has a single covalent bond between 2 oxygen atoms. He himself announced that there is only 1 electron between 2 oxygen atoms. So oxygen, single bond oxygen. What is the next? Each atom carries a negative charge. Each atom is having 1 negative charge, and he is asking to draw the dot and cross diagram for the peroxide ion. Show outer electrons only. So let's suppose I'm writing dot for this right hand side oxygen and cross for the left hand side oxygen. Now what does it mean? What does mean by this negative charge? It means that there is 1 more electron on each oxygen atom. There is 1 more electron on each oxygen atom, and you know that every oxygen atom is having overall 6 electrons. 1, 2, 3, 4, 5, and 6. And because of negative charge, this electron is basically taken by the oxygen atom. Same is the case. This left hand side oxygen is also having its own 6 electron. 1, 2, 3, 4, 5, and 6. And the 7th electron that is over here, it is basically taken, or it is basically gained from any other atom. So basically overall electron, outer shell electron, as I have told you in case of ion, 2 oxygen atoms are lying over here. Each is having basically 6 electron, 6 plus 6, and there is a 2 negative charge. So total number of electron should be equal to 14. So here are, you can count, there are 14 electron. The next thing is basically you are going to have complete octet for each and every atom, and here it is. They both are having complete octet. Now I'm going to try it again once again. Oxygen, and cross and dot, other oxygen, the right hand side oxygen, dot cross, one lone pair, second lone pair. Same is the case, dot cross, one lone pair and the second lone pair. These things are going to indicate the negative charge. I mean, each oxygen atom has taken one electron that is not belonging to it's originally, basically it is not the possession of this oxygen atom. So this is a true picture. This is the true dot and cross diagram of O2 2 negative ion, and so on. Come towards the next example. When Cl-NO2 react with NO, equilibrium is established. Finally, he is asking to draw the dot and cross diagram for Cl-NO2 molecule. Cl-NO2, once again, you can check it over here. Its valency is 1. Nitrogen is showing valency that is equal to 3. And here are the two oxygen atom. Each oxygen atom is having valency that is equal to 2. In this case, he is saying in each Cl-NO2 molecule, the nitrogen atom is bonded to the chlorine atom and bonded to each of oxygen atom separately. I mean, nitrogen atom is bonded with Cl. Nitrogen atom is also bonded with each of oxygen atom. So the basic picture is this one. Nitrogen with Cl. I'm drawing over here. Nitrogen normal valency is 3. Nitrogen is going to make the bond with oxygen. Again, nitrogen is making one bond with oxygen. So at the moment, this nitrogen is under a balanced mode, I mean under balanced condition. It is also having the lone pair of electron at the moment and so on. Now, I'm going to complete the octet around all these atoms, all these 4 atoms. As I told you, oxygen can make 2 bonds, it can share 2 electrons, or it can receive 2 electrons. Oxygen can share 2 electrons, or it will share 2 electrons, or it will receive 2 electrons, and so on. So first of all, I'm using this lone pair in dative bonding. I'm making dative bond between this nitrogen and oxygen. These electrons are basically belongs to dots, belong to the nitrogen. So in this case, again, 1. At the moment, I have wrote 4 dots, basically 4 electrons, and the 5th electron, I'm going to use it again over here for the bonding with the nitrogen and oxygen. So I have made double bond. Nitrogen is making 4 bond in this case. Now nitrogen is showing abnormal valency. I mean, it has extended its valency that is equal to 4. And in this case, you can see that in this case, oxygen is utilizing 2 electron, correct? Rest of 4 electron will be in form of lone pair. In case of Cl, this cross is this electron of Cl, and this Cl is also having a rest of 3 pair of electrons. I mean, total electrons are 7 for the Cl and 3 lone pairs, and there is sharing of 1 electron from this chlorine. Now come toward this one, I mean this oxygen atom, it hasn't utilized or used any electron. So I'm going to mark cross, all cross, I mean this oxygen accepted 1 pair of electron. There is no any participation of this oxygen towards the covalent bond. This is the dative bond, and oxygen has accepted 1 electron. So in fact, it is having negative charge on it. And as I told you, the nitrogen is, whenever the nitrogen is making 4 bond, it is going to have the positive charge. Whenever the nitrogen and any other atom or any 2 adjacent atom, they are having positive and negative charge, they will be finally cancelled out. So finally, this is the dot and cross diagram. I am going to erase the bonds and I am going to erase these line, and here it is. So this is the true dot and cross diagram one of the appropriate dot and cross diagram for this molecule that is said to be ClNO2. Now come towards another example, that is Al2Cl6. For Al2Cl6, that is the dimer of AlCl3. This is the dimer, that is the combination of two AlCl3 molecules. So I'm marking AlCl3. This is one AlCl3. You can say, roughly speaking, this is not fit to scale, or that is not the, an EPR diagram. I'm going to write another AlCl3, but I'm going to copy and paste it over here. And I'm changing its directions like that. I'm changing its directions like that. I can rewrite the Cl aluminium. Cl, Cl, Cl. And here is the aluminium. So I'm writing Al over here. Al over here. So now this aluminium atom over here and this aluminium that is lying over here, it is not having the complete octet. Let's suppose I'm marking dot for the electron of aluminium. In these cases, in these both cases, overall 6 electrons are surrounding aluminium. Same is the case if I'm showing the electron of Cl with cross. So 6 electrons are basically surrounding this aluminium. 6 electron, same as the case over here, 6 electron. So there is no complete octet. Whenever these two molecules are joined together, there is basically a dirty bond. So as this Cl is having lone pair, so this Cl can donate the lone pair of electron to the aluminium. Same is the case, this one Cl will donate the electron to the other aluminium, and here is the dirty bond. Now each aluminium atom is having 8 electron. Now the each aluminium is having complete octet. Same is the case over here. Each aluminium is having complete octet. Now I'm going to mark lone pair on each chlorine atom. So I'm marking over here, over here, over here, over here, over here. Every Cl is having 1, 2, 3, 4, 5, 6, 7. Yes, correct. 1, 2, 3, 4, 5, 6, and 7 complete. And here 7. 1, 2, 3, 4, and 5, 6, 7. Now the last one step is, as you have completed the octets, so I'm going to remove these lines. Those are called bonds. I'm removing these lines, these bonds, and here is a dot and cross diagram. You can rearrange these atoms like that, and like that. Yes, same as the case over here. Same as the case over here, in this case, and so on. So this is the true exact dot and cross diagram. That's all about this lecture. Please subscribe my channel, hit the bell icon, and share it with your friends. Thank you very much. Have a nice day.